friends, I welcome you all in this session. As you are aware, in previous session we were discussing about factorial design. Factorial design is a kind of experimentation technique wherein we analyze the effect of two or more than two independent variables on dependent variable. So, how factorial design is different from other two designs which we have seen. The first experimental design was completely randomized design, wherein we have seen the effect of one independent variable on dependent variable. The second one was randomized block design, where we have seen the effect of again one independent variable on dependent variable, given that there was one blocking variable. So, let us take an example of two independent variable and a dependent variable. So, if we take two independent variables, we can solve this example by completely randomized design experiment as well. But the point is, we will have to perform completely randomized design experiment two times, because you will have to take two independent variables separately. So, this is one way. The second way could be you take first independent variable and the second independent variable can be a blocking variable, or the third one is factorial design. You just take both the independent variables simultaneously and see how they are affecting dependent variable. So, you would be aware of that in previous session we were discussing about this question. So, we want to find out the effect on the stock price on when there are two independent variables. The first is where the stock is traded and how stakeholders are informed about dividends. So, company can trade stocks in these three stock markets, let us say New York Stock Exchange, American, and over the counter. This is the third one. So, here how you are informing stockholders either through annual or quarterly report or through presentations, right. So, we have taken data 4 times of one particular stock. So, there are, we can say that there are 4 replicates, right. So, the number of replicates are 4, right. So, the value of stock in New York Stock Exchange when the reporting system was this annual, and this was the value of the stock, then second reading, third and fourth, right. Similarly, these 4 and so on, right. So, this is a case of 2 by 3 design, right. It is you have got, let us say 2 levels of this independent variable and 3 levels of second independent variable. So, we have seen this output as well in previous session. So, after calculating all necessary statistics, let us look at Minitab output. So, this is p value, right. So, this value is less than 0.05. So, we will say that there is a significant difference in stocks as far as where the stocks are traded, right. But if you look at p value for this, how the reporting system was, so there is no significant difference. So, whether the stakeholders are informed through presentation or through annual reports, there was no significant difference between these two. And of course, interaction is again it is not there, there is no interaction effect. So, there is only one conclusion, that there is a significant difference, or the independent variable this where company stock is traded is affecting dependent variable, right. So, this is again output from Excel, this is Excel output. So, you can see here f critical is this and F observed is this, right. So, this is how you would be drawing your distribution. So, F critical is 4.41 and your F observed is this, let us say 2.42. So, you are not rejecting null hypothesis and you are saying that the reporting system is same in both the methods. But if you look at the second one, this one, right, where F critical is this is 3.55 and calculated value is 16.35, right. So, this is a rejection region. So, you are rejecting null hypothesis, right. So, we will work out this example using Minitab and you need to enter data very carefully and then we will see, we will analyze output, right. So, let us look at how to enter data. So, go to state, we will go to design of experiment and then factorial design, create factorial design, right. Now, this is general full factorial design. So, we know that the number of factors are 2 because the first is how stocks are traded and how the stakeholders or stockholders are informed, right. So, number of factors 2, go to design. So, you will get this design, right. So, A and B, so each has got 2 levels, right. So, the first has got 2, but the second has got 3 levels, right. When we say B, B means how you are trading stocks in different stock exchanges, right. So, this is your number of levels for A and B. Okay. So, this is we have got 4 replicates, right. As I said, we are taking observation 4 continuous days, right. So, number of replicates 4, click OK, then go to factors. So, you can name them, let us say how stocks are or how stakeholders are informed. So, it is of course a non-numerical one, which is whether it is annual reporting or through presentation. Okay. Then for B, where it is traded, TR, yeah, it is traded, where stocks are traded, right. So, this again text, yeah, we will need to click on this arrow, yes, text. So, these are 3 options now. So, it is let us say new NYS, New York, NYSE, New York Stock Exchange, then second is you can write the other one, and the third one was OTC, over the counter, OTC, right. Click OK, go to options, we will have, it is up to you, if you wish you can have some data store somewhere, then OK. Of course, how you are you want to have printout, whether all the graphs in just one page or separate page for each graph, we will click OK. So, this is how you should enter data, right. So, there are total 24 data points which you need to enter, right. So, this is response variable. Now, you have to be very careful, right. So, annual New York Stock Exchange response to annual the other stock exchange is 2, over the counter 4, then presentation New York Stock Exchange, presentation the American Stock Exchange, and presentation OTC. So, this is how you are supposed to do data entry in Minitab. So, this is now annual report New York Stock Exchange, annual AAC, annual OTC, then presentation AAC, OTC, annual report New York Stock Exchange, American Stock Exchange, and then OTC, again presentation, and this final data point which you are supposed to enter, right. So, this is your response variable. We will go to click design of experiment, factorial design, analyze factorial design, right. So, response variable is to be selected. So, select response variable. You can enter the significance level, which is 95, let it be like this. Let all these be there. So, here you will get lots of output. We have to just look at p value, right. Yeah, just see this. So, p value is 0.137. How they are informed? So, there is no significant difference between whether stockholders are being informed through presentation or through annual or quarterly report, but there is a significant difference. Just see this. So far as where stocks are being treated, whether it is New York or American Stock Exchange or over the counter, right. So, this is how, in fact, interaction, if you look at, there is no interaction because this value is more than 0.05. So, there is no interaction effect, only there is a significant difference amongst those 3 columns, right. So, this is what you can get as an output. You can also get f values, and of course, there are other set of information. You have got r square, adjusted r square, and so on. In fact, it's this, all these things are not needed at this point in time. In fact, you are getting a regression equation as well. So, this is your constant term, it's 2.70. So, how stockholders are informed, whether it is through annual report or through presentation, and where it is traded. So, this is a complete multiple regression equation. So, we will not see this at this point in time. So, this is the way you should solve a question on two-way ANOVA, right. There are 2 independent variables and we are seeing the effect of both of them simultaneously on dependent variable. So, let us move on to next question, which is also on two-way ANOVA. So, let us say some theorists or let us say managers believe that the training to the employees of the warehouse will reduce absenteeism, right, and they thought of doing some experiment. So, they selected workers from 4 different warehouses. So, let us say warehouse number 1 general merchandise warehouse, second is commodity warehouse, bulk storage warehouse, and fourth is cold storage warehouse, right. And there were different training sessions by length. So, there were 3 different sessions. So, you have got first session of let us say up to 0, let us say 1 to 20 days, 21 to 50 days and more than 30 days, right, sorry 50 days. Then after selecting 4 warehouses and 3 different training sessions, 3 workers were selected from each of these warehouses. So, they were put on training, the workers of these 4 stockholders, they were put on trainings on these 3 different training sessions, and their absenteeism was noted, right. So, we wanted to know whether there is a significant difference in absenteeism amongst types of warehouses, workers of types of warehouses, and going through different training sessions, right. So, we have to calculate a two-way ANOVA to determine whether there are any significant difference in effects. So, is absenteeism depends on these types of warehouses and length of training sessions, right. So, this is the data which was collected. Again here there are different readings. So, length of training sessions, first session, second session, third session, and these types of warehouses, general merchandise, commodity, bulk and cold storage. So, you have got these averages over here, right, of all these 4 rows, all these 4 columns, right, and this is the overall average, right. So, let us look at the solution to this question. So, this is the Minitab output which you would be getting, right. So, if you look at the significance level, it is, I think it is given in the question, it is 0.05. So, alpha is 0.05. So, p value, so alpha is, so p value here is 0.32. P value is less than alpha, so we will reject null hypothesis, again we will reject null hypothesis, and for interaction effect again we will reject null hypothesis. It means that the absenteeism is different in different types of warehouses, and it is again depends on different sessions, and there is an interaction effect, right. So, let us solve this question, and before we solve this question, let us look at the interaction result or the output from this particular software. So, this basically this graph, this plot is interaction effect. So, we know that this is the mean of all these 3 values which we have seen earlier as well. So, mean of all these 3 is 3.8, 2.2 and 1.7, right, similarly for all other cells, right. Now, if you look at this plot carefully, so when the training session is short length, then absenteeism is least for 4th type of warehouses, the workers of 4th type of warehouse. 4th is what? Cold storage. So, we will say that when the training session is of short duration, then the absenteeism is lowest for the workers who are working in cold storage warehouse, and highest absenteeism is where, just see this dotted point, right. So, this is warehouse number 2, it means commodity warehouse. So, at short length training session, the highest absenteeism is for commodity stock warehouse workers and least is for this. but when we when the training session is of medium duration, then the lowest absenteeism is for this third type of warehouse, right, and this is bulk storage. So, for medium length sessions, which is session number 2, cold storage workers had the highest rate of absenteeism. Just see, highest rate is here, right, it means fourth one, right. So, highest number of absenteeism is for the is amongst the workers of commodities warehouse, but for medium term session the highest absenteeism is for cold storage workers. And what about this, when the training session is the longest one, the absenteeism is lowest for commodity warehouse, right. Now, if you look at this, the absenteeism is lowest here for commodity warehouse workers, but highest when training session was of lower duration. So, we will say that the absenteeism depends on the workers of different storage warehouses, and it also depends on length of training session, and there is interaction amongst these these two, right. So, let us look at how to solve this question using Minitab. So, you can delete this output first, because it would be easier for us to see the output for second question. So, just control and delete, right. Now, we will have data entry for our second question. So, state DOE factorial design, create factorial design first. So, general full factorial design. So, number of factors are 2, right. Then you have designs. So, here you can write a number of levels first. So, there are 4 types of warehouses, right. So, this can be types of warehouse, types of warehouse, TY types of warehouse, and the other one is training session or length of training session. Length of training will also suffice, right. So, it has got 3 levels and the first one has got 4 levels, right. Number of replicates 3, right. So, we will go to OK, then factor, right. We will have text, yeah. So, here you can write down the names of warehouse: general, commodity, bulk and cold storage, right. Here you can have different training sessions, let us say 1 to 21, 21 to 50 and more than 50, right, more than 50, right. Click OK, go to OK, yeah. Now, this is how you have designed your experiment, and now the point is you have to write your response variable, right. So, this is your response or absenteeism, right. So, first warehouse general, length of training session is the shortest duration, then medium duration and longest duration. Similarly, for commodity type of warehouse, for bulk, then for fourth one which is cold storage, right. Then general, this is how you are supposed to go for data entry. As I said, if you have got large number of factors and levels, try to reduce number of replicates, right, because you would be otherwise consuming a lot of time and efforts. So, this is how you are supposed to enter data. Right. Now, you can analyze this question, DOE factorial analyze factorial design, right. So, response variable is C7, options. So, you can use confidence level as 95, click OK. Let us look at p values for this question. So, type of warehouse, p value is 0.032, which is same as yeah, I will show you, yeah, just see 0.032 for type of warehouse, just see 0.032, length of training session 0.030, 0.030, and for interaction it is 0, right. So, we will say that there is a significant difference as far as absenteeism is concerned of workers of different types of warehouses and the length of training sessions which they undergo, and as well as there is an interaction effect as well, right. So, this is how you should analyze output, and again you will be having the multiple regression equation, the R square, adjusted R square, and so on, right. So, with this let us move on to the next topic, which is on chi-square test. In fact, we have seen several analytical tools. We have seen regression, we have seen coefficient of we did not see regression so far. We have seen correlation, we have seen coefficient of covariance, we have seen ANOVA, we have seen in ANOVA one-way ANOVA, two-way ANOVA, and we have seen factorial design. But when we were solving questions on hypothesis testing of means of two samples, we have analyzed not only hypothesis testing of means of two samples, but we have analyzed variances as well, we have analyzed proportions as well. Now, sometimes in fact many times you may face a situation where you will have to analyze proportions of more than two samples. Now, in situation like that, you can't have just a simple Z test or T test, because you have got more than two proportions. Of course, you can always have two T test, you just select first and second proportions, compare them, then second and third, and first and third. In fact, there would be three separate T tests you will have to perform, but there is an efficient method available which can be used for analyzing proportion of more than two samples. So, this is a tool called chi-square test. This tool is applicable for analyzing categorical data or non-numerical data. So, we collect data not in terms of let us say on ratio scale or on rank order scale, but we collect data on frequency counts, right. So, let us take an example. Let us say there are 790 people attending one convention and 240 of them are engineers, 160 managers, 310 sales representatives, 80 are information technologies and so on. So, here what we have said, there is one variable which is categorical variable and non-numeric variable, and it has got 4 different categories, right. So, those categories are let us say engineers, managers, sales representatives and information technologies, right. So, when we have got research questions producing such type of data, they are analyzed using a technique called chi-square test. We will see in detail about chi-square test. For the time being, let me stop here. We will work out couple of examples using chi-square test in next session. Thank you.